Materials are substances or things from which objects are made. Some common examples of materials are wood, plastic, metal, glass, ceramics, fabrics, paper, concrete, and rubber. Wood is a natural material and is used for making furniture and buildings. Because it's sturdy and can be shaped easily. Plastic is synthetic material. Plastic is used to make plastic bottles and bags. Metals like iron, copper, and aluminium are strong and can conduct electricity. Glass is known for its transparency and used in making windows, bottles, and mirrors. Ceramics like porcelain or clay pottery can be used for making dishes and decorative items. Fabric like cotton, silk, and polyester is used for making clothing and textiles. Paper is used for writing, packaging, and printing. Concrete is a very strong and durable material and is used in construction. Rubber is known for its elasticity and used in making tires, shoes, etc. Properties of materials. Materials have different qualities that make them special. So here are some of these qualities: strength, hardness, elasticity, brittleness, ductility, thermal properties, electric properties, magnetic properties, optical properties, density, chemical properties, acoustic properties, biological compatibility, environmental impact. Strength is like how strong a material is. Some materials are tough and can handle a lot of force without breaking, like the steel in a bridge. Others, like glass, can break more easily. Hardness. Think of this as how tough or soft a material feels. Diamonds are super hard, while a sponge is very soft. Elasticity. If a material is elastic, it can stretch and then bounce back to its original shape. Rubber bands are a good example. Brittleness. This is about how easily a material can break. A piece of chalk is brittle because it can snap easily. Ductility. Some materials can be stretched into thin wires without breaking. Think of it like making a long string from clay. Thermal properties. This is all about how materials handle heat. Some melt easily, like ice turning into water, while others can take a lot of heat before changing. Electrical properties. Materials can conduct electricity. It will let the electricity flow through it, like wires. Others resist electricity and don't let it pass through. Magnetic properties. Some materials like iron can stick to magnets, others don't do that at all. Optical properties. Materials can be seen through like glass, partially see-through like frosted glass, or completely blocked light like a wall. Density. Density tells us how heavy something is for its size. A feather is less dense than a rock. Chemical properties. Some materials resist things like rusting or reacting with chemicals, while others can easily rust or change when mixed with other things. Acoustic properties. This is about how materials deal with sound. Some can make sounds louder like a megaphone, while others can make them quieter like earplugs. Biological compatibility. This is how important in medicine, and it means whether a material is safe inside our body or not. Environmental impact. Some materials are good for the environment, like recycling paper, while others can be harmful, like plastic waste in the ocean. All these properties help us decide which material to use for different things like building houses, making gadgets, or even choosing clothes. It's like picking the right tool for the job. If a substance can be compressed, is it soft or hard? Soft. Is aluminium lustrous material? Yes, aluminium is lustrous material. Which material is used for making pens? Plastic or metal? Is oil soluble in water? Oil is insoluble in water because it does not dissolve in water. Let's see the chemical nature of water. Water is a polar molecule, meaning it has a positive and negative end due to an uneven distribution of electrons. The oxygen atom is more electronegative, attracting electrons more strongly, giving it a partial negative charge, while the hydrogen atoms have a partial positive charge. Oil, on the other hand, is composed of non-polar molecules such as hydrocarbons. These molecules lack charged regions and are electrically neutral. So, like dissolves like, that means in chemistry, the saying like dissolves like holds true because polar substances tend to dissolve in other polar substances and non-polar substances tend to dissolve in other non-polar substances. So, oil, instead of dissolving in water, oil forms distinct droplet or layers in water as the non-polar oil molecules are repelled by the polar water molecules. So this lack of solubility between oil and water is a fundamental principle in chemistry and has significant implications in various applications such as separating oil from water in environmental cleanups and industrial processes. Name three similarities of iron, copper, and aluminium. All the three are metals. They are hard and have luster. Why is water important for our body? Water can dissolve a large number of substances. Why does metals lose shine? Metals react with moisture and gas in air. Kerosene, coconut oil, mustard oil do not dissolve in water. True, the space between the molecules of water is not taken by oils, so they are immiscible in water. Name a non-metal that has luster. Iodine. Naturally occurring hardest substance is known as diamond. Prove water is transparent. So this is an experiment that shows that water is transparent. So you have to take a beaker, fill in with water, and place a coin inside the beaker. Now observe the coin from outside. You can see the coin in the water from outside, and this proves that water is transparent. Is our palm translucent? In how? Translucent means that palm is allowing light to pass through it. So for this experiment, you have to place a torch close to the palm of our hand. You can see the light passing through it. The opposite of translucent is opaque. So in opaque, the object does not allow light to pass through. Sugar and salt are soluble in water. Yes, it's true. Sugar and salt dissolves in water. For this experiment, you need bowls of water. So we can also check whether chalk powder and sand is soluble. So for that, let's take bowls of water and add some sugar to the first bowl, salt to the second bowl, chalk powder to the third bowl, and sand to the fourth bowl. Okay. The sugar in water dissolves completely and kind of disappears. That means it is soluble in water. Okay. Whereas chalk powder and sand is not soluble in water. It does not dissolve. You can still see the chalk powder and sand in the water after mixing it. So, solids like sugar and salt dissolves and they are soluble in water. But solids like chalk powder and sand are not soluble in water. True. For separating two components, we can use sedimentation, decantation, filtration, winnowing, and sieving. Sedimentation is a natural or engineered process in which solid particles in a liquid or gas settle to the bottom of a container due to gravity. So first, sedimentation in a liquid. When a mixture of liquid and solid particles is left undisturbed, the solid particles, being denser, gradually sink to the bottom of the container. This settling process is known as sedimentation. The sedimentation in a gas. So in gases, sedimentation can occur as well, but it's often called settling rather than sedimentation. For example, when dust particles in the air gradually falls to the ground due to gravity, it's a form of settling. settling. Decantation. Decantation is a separation process that involves carefully pouring off the upper layer of a mixture of liquids or liquid-solid mixture, leaving the lower layer or settled solid particles behind. This process is used to separate substances based on their differences in density. Filtration. Filtration is a separation process that is used to separate solid particles from a liquid or gas by passing the mixture through a porous material, typically a filter or a sieve. The solid particles are trapped by the filter while the liquid or gas passes through, resulting in a separation of two components. Winnowing. Winnowing is a traditional method of separating grain or seeds from their chaff, husks, or other impurities. It is often used by farmers and agricultural communities. Sieving. Sieving is a mechanical method of separating particles or substances based on their size. It involves passing a mixture of particles through a sieve or a screen with specific openings or mesh sizes.